Hello student, welcome to our lesson today. In this lesson, we are going to look at nuclear equations. Now we have that atom is made up of three particles. We have seen earlier. We have protons, we have neutrons, and we have electrons. Now these particles can be written using upper and lower subscripts. For example, if you have proton P, which has charge +1 and mass of 1, is written as P11. Then we have neutron with no charge but with mass of 1 unit is written as 10. Then an electron with a charge of -1 and a negligible mass is written as 0, -1. Now these three will help us when we are writing nuclear equations or the equations that are as a result of nuclear radiations. Now it's also important to note that the principle of conservation is applied even in radioactive decay, which implies that the total number of nucleons, that is neutrons and protons, must be the same before and after the decay. And that way we will say that our equation is balanced. In other words, the left-hand side of the equation must be equal to the right-hand side for both total mass and the charge. We move to nuclear fission and nuclear fusion. We start with nuclear fusion. Now this one occurs when the nuclei of lighter elements are made to collide at a very high velocity and they combine, forming a larger nuclei or a heavy nuclei. In other words, the word fuse or the fusion is coming from the word fuse, which is to combine. So we have two lighter nuclei which are colliding and becoming one heavy nucleus. Now in this one, we have that the fusion reaction releases energy, and this energy is very high. Actually, it is at the rate of 3 to 23 mega electron volts per fusion. For instance, we can have a fusion of two deuterium nuclei that form helium. These are isotopes of hydrogen. Now the fusing together of nuclei to form a heavier nucleus is what we call the nuclear fission. The process requires high temperatures, and for this temperature comes from the ordinary fission bombs. Remember, we are saying that these particles have to be or has to collide at a very high velocity, and for us to get that high velocity we need high kinetic energy, and this high kinetic energy is being provided by high temperatures. Then for example, we have a nuclear fusion in the formation of alpha particles like this. In this equation we have lithium that is combining with hydrogen to form beryllium. This beryllium is a radioactive substance, and therefore it disintegrates further to give us two alpha particles. That way, this process of fission has given us alpha particles. You can be able to check whether the equation is balanced. We have 7 + 1, you get 8. Then we have 3 + 1, you get 4. So at this point, in the formation of beryllium, the equation is balanced. Then we have said that this beryllium, which is radioactive, disintegrates to form two alpha particles. Again, this we have 8 on this side. This other side we have 4 + 4, which gives 8. And the lower part we have 2 + 2 to give us 4. So again, our equation is balanced. So we have the application of nuclear fusion. It is used in the production of hydrogen bomb. Then from there we have nuclear fission. Now this one is a process where now the heavy nucleus splits to 2 or more nuclei. In other words, it is the opposite of fusion. This one is now splitting. So the process again generates a lot of energy, and this one, it will generate energy and neutron. So it was discovered that when the nucleus of uranium is bombarded by a neutron, the uranium nucleus will split into almost 2 equal nuclei. For example, is shown in this equation. We have uranium-235. It is bombarded by this neutron. Then it gives us uranium-236. This one is a radioactive substance. Then it will disintegrate to give us barium and krypton. And in that process, there is emission of 2 neutrons and energy. So in the process of nuclear fission, we have the generation of energy and the emission of neutrons. This equation, we are saying the uranium undergoes nuclear fusion, that is splitting, and when that happens, the uranium-236, which is radioactive substance, will further split to form barium and krypton. That way, we are able to get 2 nuclei and energy and neutron. Now, the protons and neutrons, we know that they are found in the center, or they are found in the nucleus. And the protons are positively charged, while the neutrons are having no charge. Now, they are kept together in that small volume by what we call the binding energy. And in the process of splitting, the process of nuclear fission, this binding energy has to be released. So the binding energy is the energy that keeps protons and neutrons inside the nucleus, which has small volume. But during the process of fission, that energy has to be released, and the energy that is released is now called nuclear energy. Then we have the emitted neutrons, this one in our equation. These neutrons, if they meet another uranium, they are going to knock them or to collide with them, and this will result to further splitting and again further release of energy. So when that happens, these neutrons that are emitted, we call them fission neutrons. These fission neutrons will bombard another uranium that will give us another fission or another splitting of many atoms, and that process will continue. And when that process continues, then it gives us what we call the chain reaction, as shown in this diagram. We have the first neutron that collided or that bombarded the first uranium. This gave us 2 neutrons. These fission neutrons will still meet other uranium neutron or nuclide. Again, they will bombard and the splitting will occur. In the process, we shall have other neutrons. The process will continue, and that is what we call the chain reaction. Now, when this reaction is triggered, the number of nucleides involved will build up very fast. The number of nucleides involved will build up very fast, and there will be release of many neutrons colliding many nucleides in their path. And the number of neutrons released is given by geometric progression. That is, in our first stage, we have 2 to power 0, which is 1. In our second stage, we have 2 to power 1, which is 2. In our third stage, we have 2 to power 2, which is 4. So it is increasing. So that way, if this one is not controlled, we shall have a very large amount of energy being released. And therefore we are saying the neutrons that are released or that are produced at every stage, they are used to sustain that chain reaction. In this process, a lot of energy is produced, and if it's not controlled, we may have what we call explosion. Now, to prevent this explosion, in nuclear reactors, boron rods are used to absorb neutrons. Now, the neutron is used in bombarding the nuclei because, one, it has no charge. Remember, neutron carries no charge, and therefore it can approach any nucleus without repulsion. That is why we are using neutron for the bombardment of our nuclides. Then from there, we have an example. The equation below shows nuclear fission process. Find the values A, B, and C. Remember, we have said that the nuclear equation has to be balanced. And therefore, to get the numbers or the values of A, B, and C, we have to ensure that this left-hand side and this right-hand side has equal number of masses. For instance, we start with the first one. We have 2 plus A should be equal to C plus 1. But we know that the mass of the helium, this one, is 4. So automatically C is equals to 4. And if C is equals to 4, then our A will be C minus 1, which is 3. Now to get the value of B, we come to the mass part, the charge part. That is 1 plus B should be equals to 2 plus 0. And when you add that, 1 plus B will be equals to 2. So our B will be 2 minus 1, which is 1. So we have the values A is equals to 3, B is equals to 1, and C is equals to 4. Then we are supposed to identify the 2 isotopes. And the 2 isotopes of hydrogen will be hydrogen, this one, 2,1, and hydrogen, 3,1. The first one we call it deuterium, and the second one we call it tritium. So these are the 2 isotopes of hydrogen. Then we move to application of nuclear fission. In this one, they are used to manufacture atomic bombs, where tremendous or large amount of energy is released within a very short time. Then when this released energy is controlled, it can be used or it can be converted to electrical energy. So it means we can use nuclear energy to get electricity. From there we have the assignment. Again, make sure that you're able to recall. If you see you can't recall, go back, replay the video, listen cleanly, and then come and attempt the assignment. So thank you, and let us meet in our next lesson.